Okay, guys, so second part of this video here, let's talk about it a bit more. Why we call them ionic bonds? Well, this is actually a good review for the previous unit. Remember that charged atoms are called ions. So we had an electron, remember, transfer from one atom to another, and we're going to talk a bit more why that is in this video. So since both atoms become charged, they're both ions, and that's why we call it an ionic bond. So one thing is we can have a positive ion if we have more protons than electrons. And that happens by actually losing electrons. If we have a positive ion, we call it a cation, by the way. And we can also get a negative ion. That happens when we have more electrons than protons. That always happens by gaining electrons. So it's always the electrons that are moving in these problems, never the protons. They're bound up in the nucleus. So a negative ion, by the way, is called an anion. And those words aren't super we're not going to hit on this super hard, but you should, if you read those, know cation is positive and anion is negative there. So let's talk about why the metal gives up an electron to the nonmetal. So let's go back to sodium chloride again. So here I have a sodium atom, and it's got 11 protons in the nucleus. And if I forgot that, I can always just get out my periodic table and find sodium and see that it's atomic number 11. So that means it's got 11 protons in the nucleus, and let's pretend now it starts neutral. So that means it's going to have 11 electrons as well. Well, we might need a brief review again from the previous unit. We're going to put our electrons into these energy levels, remember. The first energy level can only hold 2 electrons. The second energy level can hold 8 electrons. The third energy level, it gets a bit more complicated, but for now we're just going to say it holds 8 electrons as well. So let's get back to sodium here. Sodium has 11 protons. Let's make it neutral, give it 11 electrons. 2 go in the first. We can fit 1, 2, 3, 4, 5, 6, 7, 8 in the second energy level. And I've drawn the energy levels as rings. Remember, these are called Bohr diagrams. And then I need one more, because this is 2 and 8 is a total of 10. So the 11th electron's got to go out here in the third energy level. I actually could have cut that if you forget how to do that. One thing that gives it away right away is I know sodium is going to have 3 energy levels. How do I know that? Because it's in the third row of the periodic table. And I know sodium is only going to have 1 electron in its outer shell. How do I know that? Because it's in group 1 or column 1. Remember, the columns are called groups and the rows are called periods. So I actually could have cut straight to that chase there and drawn it that way. But 1 out here, it's called a valence electron, if you remember from last unit. Let's do chlorine. Chlorine, if you look it up in the periodic table, it's atomic number 17. So it's got 17 protons. Let's keep it neutral for now and give it 17 electrons. So 2 in the first. I can put 8 in the second energy level. That gets me to 10. And I can put 7 in the next one. This circle here, this open circle as opposed to the dot, represents there could be one more in there. Could be, but not in this case. So one thing we need to realize that it turns out that every atom's goal in life, its crowning achievement, is to get its outer energy level filled with electrons. So, and that we could call that its valence shell or its valence energy level. Some people call the energy levels shells. So neither one of these guys are happy. Why not? Well, look, sodium's only got 1 in its outer energy level. It would love to have maybe 8 if it could get there. And chlorine's not happy. It's only got 7. It would love to have 1 more. So now here's the thing. For sodium, it's actually easier to totally get rid of this electron. Rather than gain 7, if it gets rid of this 1 electron, it's as if that energy level doesn't exist. And then it does have a full outer shell there. So we would just drop down to the second energy level. So that's what it does. It spits the electron out. But guess who could be waiting there ready to gobble it up? Here's chlorine. Chlorine could lose all 7 of these and drop down to the second energy level like sodium, or it's far easier for it to gain 1 more. So the electron comes in there and it fills that up. And now they are both happy. Sodium has its outer energy level full, and chlorine has its outer energy level full. So, but remember now, here, before, we're switching up how many electrons we had. So in the beginning here, if I write this down, Sodium had 11 protons. Can you see that? Yeah. And it had 11 electrons. But we lost one of them. So we didn't lose a proton, by the way. We lost an electron. So now we're down to 11 protons and 10 electrons. And that gives us a +1 charge on the sodium atom. Chlorine had 17 protons and 17 electrons. It gained an electron. So now we're up to 18 electrons. That gives us a -1 overall charge. And these two will attract each other. So two different things are going on. Each one's trying to get their outer energy level full. It's easier for sodium to give up that 1 than to gain 7. For chlorine, it's easier to gain 1 than to lose 7. So they're both happy. And now that they're happy, this one is positive and this one is negative, and so they attract each other in.